All right, so now we're going to talk about rational and irrational numbers. And we're going to take a trip back to elementary school and do a little bit of long division here. So we have 17 divided by 80. So hopefully we remember that with our long division, we know that 80 is bigger than 17, so we need a decimal point and a placeholder of 0. Okay? And then we know that 80 will go into 170 2 times. So bring your decimal point up. Okay? And then 80 times 2 is 160. And subtract, then bring down your 0. 80 will go into 100 one time. So 80 times 1 is 80. And that becomes 20. Bring down your 0. 80 goes into 200 2 times. And that's 160. And when you subtract, you get 40. Bring down your 0. And 80 will go into 400 5 times. And then you're done. Okay? So 17 over 80 is 0.2125, or 2,125 10,000ths. That is a finite decimal. Now we're going to look at one that is a repeating decimal. Example number 2. We have 13 divided by 33. All right, so 33 is greater than 13, so we need to put a decimal point and a 0. Bring up your decimal point. All right, and 33 will go into 130 3 times. And so that gives you 99. And then you subtract, and you get 31. Bring down a 0, and that will go in 9 times. And that gives you 297. And then you're left with 13. You're subtracting. Bring down your 0. And we've already done this. So 33 goes into 130 3 times. 3 times 3 is 99. Hopefully you see the pattern here. Bring down that 0, 210. And, I'm sorry, not 210, 310. And then 33 goes into 310 9 times, and the pattern just keeps repeating. So this answer is, here, is 0.39 with the repeating bar. Okay, so 13 33rds is 0.39 with the repeating bar over the 3 and the 9, because the 3, 9 as a pair are repeating. It would be 0.39, 39, 39, 39, and so on. So now what does this have to do with algebra? Well, let's turn to the next example. We want to write this repeating decimal as a common fraction. So basically, we're going backwards from example 2. We're going from the repeating decimal that we found to a fraction. So let's take a look at 0.348 with the repeating bar. So we're going to let n equal our repeating decimal. So if we multiply 1,000n, if we multiply this side of the equation by 1,000, then this side of the equation becomes 348.348 with the repeating bar, okay? Because your decimal point just moves over 3 places. Remember, when you multiply by 1,000, just moves the decimal 3 places to the right. So now we can take this equation and subtract it from this one. Okay, so we can take that n equals 0.348 with the repeating bar and subtract it from this one, because we know that these two are equal and we know that these two are equal. Okay, so we can subtract that. Well, 1,000 minus 1 gives us 999. and then your repeating decimals cancel out. That's why we wanted to do that. We multiplied by 1,000, so that way we could get a whole number in front of our repeating decimal where the repeating decimal started. So we want that decimal to be in front of the 3, not the 4 or the 8. We want it in front of the 3. So that's why we multiplied by 1,000 instead of just like 10, because that would have just moved the decimal point in between the 3 and the 4, and then it wouldn't cancel out the way we want it to. Because if this continues repeating and this continues repeating, it's exactly the same thing, so they cancel out. All right, so we're left with 348, and then solve for n. So you just divide both sides by 999. And then you can divide both of those by 3, and you get 116 over 333. And that is the repeating decimal of 0.348 written as a common fraction. Now, example number 4, find a rational number and an irrational number s between 1/5 and 1/4. Well, let's take a look at a number line. All right, so suppose we have this number line here, and we've got 1/5 and 1/4. Hopefully we remember that 1/5 is smaller than 1/4, because the larger the denominator, if the numerators are the same, the larger the denominator, the smaller the fraction. Okay? And for those of you who like decimals, you could write this as 0.2 and 0.25. Sometimes that helps us to see what the value is of the fraction. So you could pick lots of things. You could say, all right, well, a rational number would be 0.21 because it ends. So it's rational. Irrational, remember, does not repeat and does not end. Okay? So this could be written as 21 1/100ths. Okay? So it is rational. It can be written as a fraction, as a ratio. Okay? Now let's think about what else would be in between 0.2 and 0.25, or 1/5 and 1/4. Okay? You could say 0.21, 211, 2111, and so on. If that continues, that's a pattern, but it's not repeating. So that's irrational. And there are lots of different numbers that you could put in here that would be rational or irrational. These are just an example of each that you could use.